So we've been talking a lot about covalent bonds. We talked about ionic bonds at the beginning. Let's get back to the bonding in metals, the electron C model, and talk a little bit more about this. We've mentioned before, metals have low ionization energies. And in a metallic solid, what happens is each metal donates one or more electrons to the electron C. It's like they're pooling electrons together. Okay, we're all going to contribute to the pot, and then we're going to share this stuff together. And so we can think of sodium metal as being an array of sodium ions immersed in a sea of negatively charged electrons. And what holds them together is the attraction between the positive metal ion and the negative C. And this explains conductivity because the electrons are free to move. They're swimming around. They're not tied to a particular atom. They're going to stay in the pool, but they can move around. It also explains malleability and ductility of metals. Because this attraction is it's not localized, it's in all directions, we can deform a metal and it's not going to crack and shatter. And then your book talks about ozone, and this is interesting in terms of understanding what's going on with the environment. Ozone is really important. It's not good to have lots of ozone down here where we're breathing, but it's good to have it in the atmosphere. And most of you, I'm sure, have heard about concerns about holes in the ozone, right? Oxygen has a double bond. Ozone has a triple bond. Ozone has weaker bonds. We did that. It's got a single and a double, and so it's intermediate. So its bonds are weaker because they're between a single and a double bond. And so what happens is the UV light is just strong enough to break the bond in the ozone. It's not strong enough to break the double bond in the oxygen. So basically what happens is the ultraviolet light comes in, and we don't want too much of that coming all the way through the atmosphere. And the ultraviolet light breaks the ozone into oxygen and an oxygen atom. And that takes out that ultraviolet photon. And then the oxygen atom and molecule recombine to form ozone. And so the ozone is up there in this little cycle, basically absorbing ultraviolet radiation for us and keeping us from getting worse sunburns than we already do. So it's a good thing, and it has to do with Lewis structures. And you can read more about it in your textbook, and I will not test you on that part.